Hello everyone, my name is Christian Castro and today I'm going to be showing you guys a web app I've been working on during spring quarter. So a little bit of background information about myself is that I do have experience building web apps. However, I've always put security towards the bottom of the priority list and I've always focused on building more and more features. So in this web app, I wanted to change all of that and make security the top feature. And so I'm just going to be showing you guys a simple web app using the MERN stack, which is MongoDB, Express, React, and Node.js. And then I'm just going to be walking through how I did authorization using Bcrypt and JSON web tokens, as well as implementing access control. And at the end, I'm going to be attacking this website I created using cross-site scripting. Okay, so let's start at the beginning. When a user enters this web app, they'll be prompted to sign up and create an account. So let's create two accounts. The attacker will be in the dark mode and the victim will be in the light mode. Here's the password, we sign up and we're logged in. Let's go ahead and create the victim, we sign up, but the username is taken. So let's go ahead and actually look at the code now. So this is the code at the client side that will go ahead and send the username and password to the server. And we have two options. If the username is already taken, then we just send that message back that you just saw. If it's not taken, then we create the hashed password using Bcrypt and we salt it just to make sure that security is in place. And so here's the function right here. And so I will attach this documentation down below in the description, but as of right now, let's go ahead and just sign in using the victim login. And now we're all signed in. And so let's just explain a little bit about what this function does and how it's stored in MongoDB. So from the client, we received this message. And so now we just want to make sure to use Bcrypt to hash the password. And we also want to store the user in the MongoDB database. As you guys can see right here, we have the hashed password for both the user accounts, as well as the Firebase ID that was created right here. And so then we just sign the JSON web token using our private token key. And we set the expiration date for an hour, so all users will be logged out after 1 hour. And once that's done, we go ahead and send the JSON web token back to the client where we will store that in the local storage. And so on the client side, after I do receive the JSON web token and I store it in the local storage, I'm console logging it just for the demo purposes. I will save it in a text editor and I will show you guys something else. So this is just a little bit of foreshadowing for right now. Okay, and let's just explain the basic functionality of how this web app works. So in here, I'm just gonna go ahead and create a secret for the victim. Let's just go ahead and add one. We'll assign it to victim's secret and we'll just write hello. So this will also be set to public, which means that every other user will be able to read or view the secret, but that's pretty much it. They won't be allowed to do any other functions like delete it, edit it, or assign permissions. And so in here, you can see that the attacker is automatically granted the viewer permission. So if I refresh, the secret will appear, but they won't be able to do any of the other functions that admin is able to do. And so quick overview on the permissions I have set. We have admin, editor, and viewer. So admin has all the permissions, able to set permissions for others. Editor can just update the message and viewer can only read the message. So let's go ahead and grant the attacker the editor mode. So I grant permissions and I refresh the page and now the editor can respond back. So they say, hello, I am the attacker. And they update it. And so if I close this, I'll just update my screen and I'll see that the message was successfully updated. Okay, now I'm going to show you guys an approach I took when building this web app that might have not been the best and why. So initially, when I was implementing these permissions based on the user roles, I had just deleted the buttons to edit it on the client side, right? However, if a user was using a REST client such as this right here, this is a REST client called Boomerang. So I'm still able to send the request even if I don't see the button initially. So if I just copy the secret ID, and this is also assuming I know the correct endpoint. So let's go ahead and just try it and I'll show you guys what I did to prevent this from happening. So if I just press send, I'll get a node token provided, meaning that a user has to obviously be signed in to make this request. So let's go ahead and use the JSON web tokens I saved. So let's go ahead and initially assign the attacker's JSON web token. So I'll go ahead and press send, and we get 403 forbidden. The attacker is not authorized to delete this secret. And on the client side, I don't want to even show the delete button, but on the server side, I also want to make sure I have security practices to make sure that any user making the request is authorized to do so. And so now we can just attach the victim web token. So let's go back here. And so the victim web token should be allowed to delete this request. So when we press send, we'll get it okay. And then when I just update the client side, the secret is now deleted. And so a user or an attacker could make that request using Boomerang or another REST client. However, this could also fix a bug, such as if I assign the permission admin to the attacker, they're now able to see the delete button. But let's say I remove the permissions, they still see the remove button, but they're no longer have access to delete this secret. So if I didn't have those security practices on the server side, this attacker could delete the secret just because they see the button. So if I go ahead and just delete it right now, access denied. So I did implement those features on the server side to always check that the user has the correct permissions before they're able to complete the request to the MongoDB database. And so if I now refresh it, the secret is gone, and not because it was deleted, but because they don't have the viewer role. The secret is still here on the victim's side. Okay, so now that I just went over the basic functionality of the web app, I wanted to discuss the type of access control I chose. So I chose to go with discretionary access control. I could have gone with role-based or entity access control, but discretionary access control made the most sense. It works similar to how Google Docs works, where the admin or the creator of this secret will go ahead and be admin. They're able to do all the functions such as deleting, editing, or assigning other permissions. And they can assign other users these permissions as well, or they can remove them entirely. So I felt like the flexibility that comes with DAC was very beneficial for this type of project, and it worked very well at the end. Let me also show the database. So now here is the database where I'm storing the secret. Notice how you have the user ID. This is the user that created the secret. It also has the username, title, description, and the permissions. So in here, I will have the user ID. This is the same as the one who created it, right? And they're just going to be assigned the admin role. If I go back in here and I let the attacker have the editor permission, I'm just going to grant it and then refresh here. Notice how I have a second entry in the permissions array, and this will just have the user ID, which is the attacker now, and it will be assigned to the editor permission. Okay, and so now I believe the only other functionality I have in this web app that I haven't showed is the ability to actually delete the secret if I'm able to. So I was the admin here, so I'm just going to delete it, and then I can also just sign out right now, and I'll be back here to the login page. Okay, so now I showed you guys exactly how the web app works, how I implemented authorization using Bcrypt, and how I implemented discretionary access control. I want to go ahead and now try to break this website using cross-site scripting. So let's go in here as the attacker and insert a script that will run. So in here we have an image tag, and this image tag is going to be inserted directly into the DOM. React doesn't initially have this, but I did something else that I will show you guys after. Let me just explain how this tag will work. So it will be inserted into the DOM. It is an image tag that has a source that is invalid, and so this onError function will go ahead and run because the image URL is invalid. And so what it's going to do is it's going to open up a new window location, and it's going to go to this URL. So let's go ahead and just make this public. That way everyone can view it. So I'm going to press add a new secret. I'll be taken somewhere. Let's just close that out. And then when I refresh, this is the victim now. It will just have viewing access to it. So I'm going to refresh, and I'm going to be loaded into a zip. So I thought that was really funny, and it's something that I implemented, but I had to initially tell React to turn off its feature that will escape characters and prevent this type of attack. So let's go ahead into the code right here. So let me expand this. So right here, I'm gonna have this description. So this is the description that I showed you guys that has the image tag. This is going to be dangerously inserted into the DOM without React's escaping method. And so that's why this cross-site scripting works, is because we're not checking the user input, we're just trusting that they don't have a malicious script, and we're just inserting it directly into our DOM. That's really bad, so I thank React for implementing this escaping mechanism, so we don't have to worry about changing up the characters ourselves and watching out for these malicious attacks. So now if I just go ahead and replace it with the normal p tag, I can go back here and I'll still see this image tag, but now React's escaping the characters, which just means that they're replacing all of the equal sign or greater than sign with this just display ASCII character, I believe. And so that's why it's not working here. But beforehand, it was being directly inserted into the DOM, which is really bad. And that was one way I prevented it. Okay, now just to wrap things up, I want to say thank you for watching this video. This was just 1 out of 3 projects that I've been working on this quarter, but this one dove really deep into best security practices in web development, and I think the things I learned, such as protecting all my server API endpoints, was really important, making sure that whoever makes the request on the client side has the correct permissions, and checking that on the server side. That was probably the most helpful thing I learned in this project, but I also learned that implementing type of access control is a lot harder than I initially thought. And I felt that the approach that I should take to implementing the access control is very important. I believe that the one I took in this project was pretty good. I know that it might have problems scaling, but as of right now, for this simple web app, I believe that it was good enough. And I also learned a lot about authorization and how Bcrypt and JSON web tokens actually work. Usually I use Firebase for authentication, but I thought this was a nice change of pace. And the last thing I learned was just the cross-site scripting, and I thought that was very beneficial because I did not know how React escapes characters for me. And so I do thank them for that. But this was nice just to see, just to turn that part off and see that I can directly insert malicious scripts into the DOM and have code run. So I thought that was a very important thing I learned. But yeah, this is pretty much the project, and thank you for watching this far if you did.